Okay, quick introduction to the second method. The quick introduction is called perfect square trinomials. Now, in math, we have expressions, we have trinomials. Remember, trinomial is the one that has 3 terms. We have trinomials that have special shape, and let me write down this special shape of a trinomial. So if we have expression that has the following form, that expression has something squared in the first place, then it has 3 terms, as I said, right? So it's 1, 2, and then 3. Then it has something else squared over here at the end, and in the middle it has 2 times A times B. So in other words, well, it's like double product of those things that are being squared on each side. So if expression has this kind of form, it's called perfect square trinomial because it can be written as a square of just A plus B. So that's how, that's kind of interesting, but yeah, that's how it works. So let me give you an example so it makes more sense. So for example, if I have expression, let's do x squared plus 6x plus 9. I'm claiming that this expression is the perfect square trinomial. It means that it follows that pattern. It's not obvious right now because we don't clearly see like A and B here in that structure. But I'm claiming that it has that structure. I just have to kind of like unhide it, kind of show you that what is what here. So for that, I have to rewrite things a little bit. So now x squared, I'm gonna keep as it is because, well, we have to have squares. So my goal is right now to have square on one end, square on another end, and double product in the middle. Now square on the left end I already have. Now that 9, I can also write as a square, right? I can write it as 3 squared. So I'm going to put it here at the end, plus 3 squared. Now I have another square on that other end. And then do I have the double product in the middle? Well, I do. So if I put 2 with the double product times the first thing that was squared, that's x, and times the second thing that's being squared, it's 3. Then altogether, I'm going to get 6x, which is that middle term. So see how I like decompose a couple of things, I wrote them differently, and now hopefully you can see that it follows that pattern. So it's like A squared plus, and here it's B squared plus, and in the middle it's 2 times A times B. This is A, this is B. So hopefully you can see that analogy. And then according to what I wrote here to start with, well, I said that it's called perfect square trinomial because that expression can be written as the square, as a square of the expression. Here's the square where I put just A and just B. Well, for my example, what is A? Well, A is just x. That's what I had in the first place. And then B, it's whatever is squared at the end. Well, it's 3 that's being squared. So it's x plus 3 squared. And well, that's kind of like the whole idea or the purpose of knowing or recognizing perfect squares is to be able to write them in that short form, in that squared form. And to finish this example, I'll just kind of demonstrate that, well, yes, indeed, it can be written this way because if I take x plus 3 and square that, well, it's same as x plus 3 times x plus 3. And now as I multiply things out, it's going to be x squared plus 3x, and then I'll multiply this way. So it's another 3x and then 9 plus 9. So that is x squared plus 6x plus 9. See, that's what we start with. So yeah, that looks right. We can write, or at least like this example illustrates that, yeah, this property works. Okay, now we're going to practice a little bit more of those perfect square trinomials. But before we do that, let me write down one more formula, it's going to be very similar. It's just another case that we can have is that the perfect square trinomial can have minus sign here, minus 2ab plus b squared. And the only difference that it makes is that when I put in this condensed form, in the perfect square form, it's going to be a minus b. So basically, this minus sign will result in a minus sign here. Okay, why do we need that? Or how we'll be using that? Well, my next example will kind of demonstrate the idea, but the question is, we're not solving equations yet, just, you know, in a few minutes we will start, but idea will be the following. If we have, so that's gonna read this, let's write, obtain a perfect square trinomial. The reason I say it says obtain a perfect square trinomial because I'm not going to give you a trinomial. It has 3 terms, right? That's where the name comes from. I'm not going to give you all 3 terms. I'm only going to give you the first 2 terms, and so it's going to be our first example. So for example, x squared plus 10x, and the question will be to obtain. Well, it says here to obtain the perfect square trinomial. It means that guess or figure out what number to put over here so that it becomes a perfect square trinomial. And this is how we're going to think about it. For this first example, I'm going to write things out, but for the next example, we'll use the shortcut. That's a good news because it means that we're going to be able to answer this pretty quickly. Now, how I'm going to write this aloud so we can understand where the shortcut comes from. Well, I know that perfect square trinomial has, well, this form a squared plus 2ab plus b squared. So a squared part I already have. This is x squared. This is a squared part. But now the middle part is 2ab. Well, it's this 10x, but things are kind of like hidden inside it. So I'm going to write it out. Instead of 10x, I'm going to put 2 times something times x. Now, what is this something? What is this something that I skipped that I have to write that will make 10x? And by the way, the reason I start with 2 is because the formula itself right here, see how it has 2, or actually I'm using 1 with a plus. So right here. So I'm trying to match this. Well, that's the reason I put 2, because formula has 2. But what is that number that I have to put next to 2? 2 times what? So that, yeah, that's 5. So that, you know, I'm not really changing anything. That's right. So I have to write actually 2 times 5. 2 times 5. And now 2 comes with a formula. X is what I call a squared. Well, and it means that that number that I got here that kind of appeared by itself, that must be b. Well, if I'm trying to create this pattern, well, that has to be b. And if that's b, it means that at the end, I have to place b squared. So that's going to be 5 squared, right? And by kind of seeing what's hidden inside 10x, that's 5 is actually hiding inside 10x. I now know what b should be and that has to be squared at the end. That means that the missing number right here is 5 squared. But what is 5 squared? Well, 5 squared is 25. Yeah, 25. 25. So what we just found out that, and I'm just going to rewrite it so it looks a bit cleaner, that if I start with only x squared plus 10x, then once I add 25 over here, then this becomes a perfect square trinomial. And that means it can be written in this short form, something squared. Can you guys figure out, and again, we're just starting this topic and things are, you know, a little bit interesting, but can you figure out, can you remember if you understood that? What should now I put inside the parentheses here? So what's going to be the condensed form for that trinomial, for that perfect square trinomial?
X plus 5 squared.
X plus 5 squared, very good. That's exactly right. So here I put x plus 5 and then squared. So inside the parentheses, we always use a and b, but without squares, right? What is squared in the first place? It's x. Well, then put x inside. What is squared at the end? Well, it's 5 squared. Well, then put 5 inside. So kind of like that square is kind of like outside now. Yeah, that's right. So, and that's going to be a kind of the idea of obtaining a perfect square trinomial by kind of finding the missing number. Well, for this first example, as I said, we kind of try to understand the logic, but what would be the shortcut? So we figured that the missing number was 5, right? That was the missing number or the hidden number that we had to square at the end. But what's the relation between, or how is 5 related to 10? Well, notice that it's just half of 10, right? Well, because we separated 2, and that's how we discovered 5, but basically 5 is half of 10. Well, it's going to be our shortcut. We don't really have to go every time through this, thinking and remembering and analyzing. If we just remember that that missing number that we have to square at the end will always be half of that middle coefficient. So let me show you one more example. So you can see how it works. So let's say x squared plus, oh no, I already had that example. Let's do plus 16x, like that. And the question is, what is the missing number I have to put here so that it makes or creates a perfect square trinomial? Well, that's how we'll think about it from now on. We're going to take that middle coefficient, which is 16 in our case. We're going to divide it by 2, and that is 8, right? That is 8. So it means that within 16, we have, well, we know 2 times 8. So 8 is the hidden number this time. And that's the number that has to be squared and added at the end of that expression to obtain perfect square trinomial. So I'm going to kind of put everything into one step. I'll say take the middle coefficient, divided by 2, and then square all that. So it's 8 squared. And the result, which is 64, has to be put over here. So it's like make that loop. So it's number 64 that has to be placed there, and that will create a perfect square trinomial. X squared plus 16x plus 64. And now that is the perfect square trinomial. Very good. So, and then the last thing that we would always, well, we would have to finish this with, as we start solving equations, we would have to put it in the short or condensed perfect square form. So it's always something squared. Now, what do I put inside? What expression should I place inside?
X plus 8.
X plus 8. That's right. X plus 8. Now, one more example like that, and then we're going to see that within the equations. But if that makes some sense, if you kind of starting to get the idea, then it means that, I mean, you kind of already almost learned how to solve equations using this. But the last example, I just want to show you something with the minus. So let's say it's x squared minus, let's do 12, minus 12x. So here's the expression, and we want to obtain a perfect square trinomial. So we're trying to find some number to add here so that altogether it follows that special pattern that we call perfect square trinomial. Okay, so we were talking about the shortcut. It's when you take the middle coefficient. Now the middle coefficient is negative 12 in this time, right? So it's negative 12. You would divide it by 2, and since that 2 is not just like a random number, right? It's kind of comes from that formula. It's always going to be 2. So right here, it's always 2. And then you'll have to square. So that's negative 6 that I have to square. That gives you positive 36. And that's what you'll write in this spot. So plus 36. And now that is the perfect square trinomial. And then my last question here will be, what number do we have to, what expression do we have to place inside the parentheses?
X plus 6.
x and then 6. But notice how we have minus here. So they're kind of two
-6.
spots, -6, right? So it's going to be x minus 6. And there are a couple places to catch that minus sign. So one place is the fact that it was -6 that we're actually squaring, right? And then b, or what we put inside the parentheses, like a and b, right? So b, in fact, not 6, but -6. So that's one way to catch negative. And the other way to catch negative is by, seeing that trinomial, or I guess original expression had minus sign. So if the original expression has minus sign, you will have minus sign inside the parentheses. If the original expression had plus sign here, well, you'll have plus sign inside the parentheses. So no questions. Okay, then we're gonna start solving equations. And the second method where we're going to use all that is called solving quadratic equations by completing the square. Now, completing the square, this wording, it's pretty much same thing as to say obtain a perfect square trinomial. So, and it's completing the square is like very common technique in math and algebra. Like it's being used all over the place, up to, I don't know, calculus and beyond. It's like super popular technique. And it's always called, well, complete the square, or by completing the square. But since we just practice something that, well, essentially what we're gonna do, I could rephrase it and say, solve quadratic equations by finding or by obtaining a perfect square trinomial. So what we just tried, we will have to do. So that's called completing the square. Like this expression here, it's like complete square. So that would be our goal. Okay, let me just give you a few examples. Here's our first quadratic equation. X squared minus 10x plus 16, let's say 16, equals 0. Now, when we look at this equation, at the left-hand side, and this time we have all terms present. So completing the square method is applied when you have all 3 terms. You're not missing any terms. As we look at this expression right now, do we have the complete square or not? Or do we have a perfect square or not? Well, we do have x squared in the first place, right? Something squared. And it just happened that we do have 16 on the right hand, on the other end, right? Which is 4 squared. But is it altogether a perfect square trinomial? Remember, besides squares on each end, we also have to have their double product in the middle. So the double product would be 2 for double times the first thing that was squared, that's x, times the second thing that we're squaring, which is 4. But notice that that gives me 8x, not 10x, right, or negative 10x. So that means that what we have right now, it's not following the pattern for the perfect square trinomial. And all equations, or like majority, or 99% of the equations that you will be given, they will not follow that nice pattern, even though, it may seem like they are following, but they will not be following. And that's going to be the point. So, you know what, I'm going to erase that because it was more like show you that what we have here right now is not a perfect square trinomial, but we want to obtain a perfect square trinomial. And this is how we're going to do it. So in the first step, well, the idea is the following. We're going to keep the first 2 terms. We're going to use them to build up the perfect square trinomial. But obviously, the number that we have at the end, plus 16, is not the right number. We just checked, and altogether, it does not make a perfect square trinomial. So actually, 16 is not the number we want and need there for perfect square trinomial. And right now, it's kind of like on the way. We don't want it there because it's not the number we need. So in the first step, we're going to get rid of that number. Well, we're going to move that number and put it on the other side. So it's kind of like out of way, and it doesn't confuses. So step 1 is to subtract, or add or subtract, or in other words, to get rid of that constant at the end. So I'm going to have to subtract 16 in this case, since it's plus 16. So 16 minus 16, that goes away. And I have, now I have x squared minus 10x. Now, after that, I will need to figure out what number to insert to make perfect square trinomial. So I'm leaving some space there. And now the right-hand side is 0 minus 16. That's negative 16. Okay, so far what I did, I just removed the number that I didn't really need it for the perfect square trinomial. Now it appears on the other side. Okay, after that, after you remove that number, the constant, now you're going to be working on obtaining the perfect square trinomial. In other words, now you're going to be working on finding what number to place here so that the left-hand side creates a perfect square trinomial. And that's what we just practiced, like exactly what we just did over here. How do we obtain it? So see if you can remind me. So what is like the first step here? What do we do with negative 10?
You divide it by 2.
Mm-hmm. So we divide it by 2, very good. So we take negative 10, we divide it by 2, and then what do we do with that quotient?
Square it.
We square it, very good. So that becomes negative 5 squared. Negative 5 squared is 25. And now that is the number that we have to place here, right? So we're going to insert 25. It's like, well, what does it mean inserting 25? Now we have an equation. So before we just had expressions. And we could just, insert something to the expression or add something to the expression. But now it's an equation. Remember how equation has to be balanced. That's why when we removed 16, well, we subtracted 16 on the left and then we subtracted 16 on the right to keep everything balanced. Now I'm saying, well, I want to have 25 there because that will make perfect square trinomial. So I want to add 25. As I add 25 on one side of the equation, now it's out of balance because like I added 25 pounds on one side of the equation. To bring it back to the balance, I have to put 25 pounds to the other side. So that means that when you figure out what number to add, you have to add it to both sides. And that's very important. Otherwise, you're not going to get the right answer at the end. Add to both sides. Add to both sides. That's number 25. This one over here. Add to both sides. Okay, and guess what? We're almost there. I mean, the rest is actually not that hard because after we obtain perfect square trinomial, now we're going to put that in that condensed form. So what is the condensed form of that perfect square trinomial? It's something inside the parentheses and then the whole thing is squared. So what do I place inside the parentheses?
X minus 5.
X minus 5. Very good. X minus 5. Just X and just, well, that kind of that minus 5. You can think this way. Minus 5. That's the left-hand side. And on the right-hand side, of course, we just need to combine negative 16 and 5. Negative 16 plus, no, 25. Negative 16 plus 25 gives me 9. Right? That's 9. And that's where I placed it. 9. Okay. So, I mean, we haven't solved the equation yet, but do you know what to do after that? Do you recognize this? This type of equation, or so basically we put our original equation in a special form. And what is that form? That form is something squared, x minus 5 squared, and just a number on the right hand side. How do we proceed from here? Like, what's the next step?
Square root?
Square root? Exactly. So from here you just have to square root each side. The left-hand side and the right-hand side. And this is the idea of this method for solving quadratic equations. You obtain a perfect square trinomial, and we're going to finish it in a second, but you obtain perfect square trinomial that can be written as square of something. That's our last line. And as soon as you have square of something and just number on the other side, well, you can always apply the square root property that we already know how to use. Yeah, so that's the point of obtaining perfect square trinomial, so we can have like this condensed squared form. Square cancels the square root, or they cancel each other out, so it's x minus 5 on the left. Okay, so tell me what's the right hand side.
Is it square root 3?
It's going to be, okay, so it's going to be square root of 9, which is 3. You're right. And then one more thing, well, kind of one more thing I have to write there, so I'm going to write 3 like that. And what else?
Add the 5. So you get that.
We will. Okay. you're exactly right. It's going to be our next step, but I still forgot something. So it's not just 3, but what else? So when we square both sides, what do we need to remember to write?
Plus and minus.
Plus and minus. Very good. So it's actually not just 3, but positive 3 and negative 3. So we got 2 answers here, positive 3 and negative 3. And that always happens when you square both sides. And then, yes, we're going to add 5 because we need to solve for x, right? So the last step is to add 5. And this time, okay, so plus minus 3, it means that we have 2 answers that are like 2 numbers. So we can just putting them in one expression. But this time, 3 and 5, they are integers, right? So we are able to combine them together. So it means that in this step, it's worth, it kind of doesn't matter how you organize your work here, keep it together or separate it, but separating them is actually a good idea not to get confused. So basically from here, I get the following. So what I mean under separating is that for one, I'm going to put positive 3 plus 5. And for the second one, I'm going to put negative 3 plus 5 because, well, it produces 2 different answers. So positive 3 plus 5, it's the first case, and then negative 3 plus 5. So yes, I separated plus and minus 3. And then each I can evaluate. So when I get 3 plus 5, I'm going to get 8. And then negative 3 plus 5 gives me 2. So I got 2 answers, 2 and 8, or 8 and 2. So these are 2 solutions to that equation. I'll use y. I'll switch from x to y. Doesn't matter. But just just for the change. Y squared minus 4y plus 5 equals 0. Again, the question is to solve this quadratic equation. Well, we can see second power and all 3 terms are present. Solve this quadratic equation by completing the square method. So one more time, the steps that we have to take. So in the first step, our goal is to obtain perfect square. And the constant that we have at the end is never going to be the right number for completing the square. It's going to be, number that would not ever work. So that's going to be the number that we'll need to get rid of or move it out of sight. So we're going to have to subtract 5 so that we can create a space, in a sense, for the right number. So this is what I have. Y squared minus 4y, and plus, and here I'm going to insert the number that will create perfect square trinomial. And then on the right-hand side, I already have negative 5. Now, as soon as you made up that space for that number to insert that will create the perfect square trinomial, now figure out that number. Like, what is that number? So how do we obtain this number? So tell me what I need to do to figure out what to put here.
That's the divide by 2 part, right?
That's the divide by 2 part. Very good. So it's taking the middle coefficient, number in front of x or y, and that's negative 4 in this case. Dividing it by 2, it's always 2, so that number always the same here. And then raising that to the second power, right? Because number at the end that we're trying to insert should be square of something. Okay, so negative 4 divided by 2 gives me negative 2. And once I square that, I get positive 4. So that's the number that I will be inserting here. So I need to add 4. Okay, what else I need to do right now? So I inserted 4, I added 4. What else I need to remember to do? Something that's very important.
Square it on the other side too, right?
Exactly. So we add 4 on the left, and then we have to add 4 on the right to keep our equation balanced. So on both sides. When we're solving an equation, it's adding number on both sides. Okay, now we'll rewrite the left-hand side. So the whole point of doing all those steps is that the left-hand side can be written in a different form, in this condensed squared form, in the form of a perfect square. So it's square of what expression? What is inside that inside the parentheses?
X minus 2.
Right, so yeah, y minus 2, you're right. Y minus 2, so yeah, so that's pretty much comes from here. And what's going to be on the right-hand side? What do I put over here?
-1.
-1. Very good. And it comes from, from the right-hand side when I combine -5 and 4. -1. Perfect. Now, as soon as you get to that step, it means that you're very close to the end, because now you just have to get rid of that square on the left by square rooting the left-hand side. That square cancels the square, but you also need to remember to put square root on the other side to keep the equation balanced. So square root both sides. The left-hand side is y minus 2. Now the right-hand side. So what do you think is the right-hand side?
Is it still going to be plus or minus the 1?
It's still going to be plus or minus. Very good. So that's one thing. Always plus and minus when you square both sides, no matter how that square root looks like. Plus and minus kind of has nothing to do with what's inside. So you put plus and minus as I just did, and next you start thinking, okay, and what is the number? What do I get there? So for us, it's square root of -1. So what is square root of -1? I. So that's just basically I. So it's plus and minus I. Again, you have two numbers there, positive I, so plus I, or just I, and then negative I. So these are two options. And then to finish this, you would need to get y by itself. You will add 2. So plus 2 on the left, plus 2 on the right. Now, can I combine the right-hand side? Can I combine I and 2 together? We'll only be able to write them right next to each other. I'm going to start with 2 because remember, now we're dealing with complex solution of the quadratic equation. So I think that's our first. No, that's not our first example with first solution with complex numbers. But at that point, I forgot to mention that, well, quadratic equations can have solutions that are complex numbers. And here's another example. Remember, the complex numbers have special form, and usually we write in standard form, we write the real number first, and then we put the imaginary part. Well, so I put 2 plus or minus I. This creates 2 solutions. The first solution is 2 plus I. That's solution number 1. I put comma and write down the second solution. Second solution is 2 minus I. So these are 2 solutions. And we already solved, quite a few quadratic equations today, and each had 2 solutions. What I need to tell you is that the way we check answers for quadratic equations, or solutions for quadratic equations, is the same way as for linear equations. If we take each solution, well, one at a time, and plug them into the equation, then they should satisfy our equation. So if I take 2 plus I, let's say the first solution, 2 plus I, and plug that into my equation for y, so if I put 2 plus I, I'm not going to do that, I just kind of explain the idea. So if I put 2 plus I over here, and then square that, and we learn how to square numbers like that. And if I put 2 plus I over here, and then if I simplify all that and combine like terms, then I will get the true statement at the end. So I will get 0 equals 0. So it should satisfy this equation, and same true is 2 minus I. So essentially, solutions have same kind of meaning for quadratic equations as for any other types of equations, including linear equations. So solution should satisfy the equation. It should make it true when it's plugged in.